Okay, section 10.3 has to do with discounting of notes, promissory notes. So the bank discount then is determined by taking the face value times the discount rate as a decimal, changing the percent to a decimal, and timesing it by time. And again, time is always going to be in years. The proceeds, or what the person is going to get from that promissory note, is equal to the face value minus the bank discount. And we'll play with those here in just a minute. And then the effective interest rate is going to be determined by taking the bank discount and divide that by the proceeds times the amount of time that it was for. So there's a couple of good formulas here. As always, I strongly encourage you to read the sections prior to doing them. There's a lot of good information in there, a lot of good business terminology, and then it also is how to apply the math to that. So let's see how that works here. Let's take a couple of these problems. Okay, the face value, number one, they've done the example, so I would just figure I was going to kind of go over how they got that. Discount rate of 13%, so they're going to change that right to a decimal. Term is 6 months, or a half a year, remember, so it's always in time is in years. So it's going to be 4,500 times 0.13 times 0.5, and that's where they've got the $292.50. And then the proceeds, you subtract the $292.50 from the 4,500, and that's how they got the 4,207.50. Okay, so let's do another one of those. Let's look at number 2 here. Okay, so we have a face value of 235. We're going to times that by 113, and we're going to multiply that by 50 days, so it's 50, and then divide that by 360. So we're going to get $3.69 here. Okay, so then we were going to subtract. We have $235, and we're going to subtract the 369, and then the proceeds then would be $231.31. So again, pretty straightforward, not trying to trick you or do anything weird here, just pretty much doing the math and applying the formulas. Okay, the next section is talking about simple discount rates and the bank note with maturity days. So problem 6 is done for you. And so again, we're doing exactly what we did before up above. Okay? And so the discount then after 80 days, let's just check the math there to make sure they're correct. 16800 times 0.1, and the term is 80 days, and we're going to divide that by 360. So they did. That's how they got the 373.33, and they rounded that down, and then they subtracted that. Okay, and then they counted then on the calendar then from June 3rd 80 days, and that's how they got the August 22. Okay, so let's do the same thing. We have $80. Let's see how do I do that here. I think I can get it here if I slide this up a little bit. So I have $800 times 0.121, because we're moving that over 2, right? Times term is 109, and we're going to divide that by 360. So we get our discount then is $29.31. So we have that. So then to get the proceeds, we would take 800 and subtract it from, or take 29.31, subtract it from 800, and we would get 770.69. Okay, well, the maturity date then is, okay, we have to count up 109 days from September 3rd. Well, September 30th, so to get there we have 27, and October is going to have 31, and November is going to give 30. Okay, so now we're up to 88. So we're going to subtract 88 because we're getting close now. So we're going to have 21 days left over. So that's going to mean then December 21st is going to be the maturity date. So it's just calendar to figure out that part. Let's continue. Okay, number 11. And now we're adding the effective interest rate of the discount. So in order to find that, we do exactly what we did before. Take this, change it to a decimal, multiply the term, we get the discount, we subtract the discount. And then they do a little finagling factor. Okay? So the effective rate then is going to be 1. So the difference, so the proceeds then, so we got 132.30, and that's going to be over the purchase price. I'm just going to pause that for a second. So again, in order to do the effective interest rate, we take the bank discount and we put that over the proceeds times the time. And the time is 126.360. So let's go ahead and get that bottom number first. So we would have 257.67 times 126 divided by 360 equals, I'm going to write it over here, 898969, or 70. Let's just make it 70. It's around that. Okay, so then we take the 132.3 and we divide by 898.7, and we would get then an effective rate of 14.72, which is exactly, oops, turned it already there, 14.72, which is exactly what the book has. Okay, so let's do another one of those. See if I get my calculator to turn the right way here. There we go. Okay, so change this to a decimal, plugging in our numbers here. We would have 6505 times 0.1039 times 73 divided by 360. So our bank discount then is going to be 137.05. Okay, in order to get our proceeds then, we would subtract what we would have gotten minus the 137.05, and then we would get 6367.95. Okay, so that's the easy part, straightforward on that one. Now the second part, then they're going to ask you to then get the effective rate. So the bank discount, so in this case we have 137.05, and that's going to go over the proceeds times the time. Alright, so see if I can put this on here so we can all see it. So let's do that number here, since we still have it in the calculator, times 73 divided by 360 equals 1,291.28, and that's still going to be over the 137.05. So then we would go back 137.05 divided by the number that we just created. We get an effective rate then of 10.61%. Okay. We move it over on the calculator. All right, let's continue. Lots of stuff in this section here. Okay, number 16. I have a face value, had an example here of a face value of $2,500. The interest rate was 12%. Maturity date of the note was March 4th. It had 70 days in the term. It's mature on May 13th. Maturity value was this, so they had $58.33 in interest. Date of the discount was this, they had 28 days in that period. Proceeds and the discount rate. So let's use this example to show how they got all of this. So let's get our maturity date first, since that's just kind of going in order here. So December has 30 days, so we would have another 18 days in December to get to January. So let's go ahead and subtract that. Okay, for 31, so I have 19 days. Boy, I lost a day in December there. Okay, so that gives you 31. So that means that it's on January 31st then, is the maturity date. Okay, so that's pretty straightforward. So the discount period, let's go ahead and finish that since we're working with days. If it's due on the 31st and they discounted on the 19th, that's only going to be 12 days in the discount period. Okay, so let's go ahead and figure out the maturity value. So let's go ahead and put our calculator going back here. So we have 4,000 times 0.104 times, we have 50 days in the note, and we're going to divide by 360. Okay, so we're going to have interest then of 57.78, and when we round that. So the whole, and we add that on to the face value, so our maturity value then is going to be 57.78. Okay, but they're going to discount that a little bit. So we have to go back here to our maturity value. So let's clear all of that out of there. Okay, we're going to times it by the discount rate of 15%. Change that to a decimal, 0.15, but we only have 12 days. And then divide that by 360. So they're going to subtract then $20.29 off of this note, okay, because that's the discount, so they're going to buy that off of that. So 29. So then you would just simply subtract that then, and you would get 4037.49. Okay, so it's just a lot of little steps, and that's what they did in order to get your example, or the example here in 16. All right, so 17 is technically yours, but I went ahead and did it because I wanted to show you how they got those. That's part of your homework, and it's an odd, but I wanted to show you how they got all those steps. So just kind of slow and easy. Okay, T-bills. I said there was a lot in here. How they got this? Okay, they changed it to a decimal, multiplied it. 1/4 of a year, got an interest of $195. They subtracted that off the purchase price of the 15 thou. Okay, and then they took that difference. Remember, we did that up here, so they had that difference over for 1/4 of a year times the time would be 1/4, or 0.25. Okay, and then that's how they got the effective rate. Okay, in fact, let's just do that on the calculator to show how that worked. So we had 14805 times 0.25 is equal to 3701.25. This moves over. We didn't do anything with that. So we take 195 divided by 3701.25, and that's how they got that. See, we move the decimal over. That 26 becomes the 27, so that's how they got that rate. Okay, let's do another example. let's do 22. So again, we're going to determine the interest. So we would have, clear this all out of here. So we have 50,000 times, move that over 2.044, and 26 is going to be half a year, so that's going to be times 0.5. So we're going to have interest then $1,100. Well, in order to get the purchase price then, it's just simply subtracting then the 50,000, subtracting the 1,100, and you would have then, okay, so then we have to go back and do our calculations to get the effective interest rate. So we would have that 1,100 is going to be over 48.9 times that 0.5 again. Okay, so if we have this, we can just divide that by, or divide it by 2, because that's 0.5, right? So this is our new number. So we'd have 1,100. Whoop, too many zeros. Divided by 24450. We move that over here. My effective interest rate is going to be 4.49. So they might call that 4.5%. All right. Just slow and easy, following the formulas. Okay, I'm going to do a couple of story problems here for you and just for the next section. And so this is the math so far for the first 3 sections then of the homework.